Welcome to my channel. This is Java Data Structures and Algorithms course. And today's tutorial is about implementation of priority queue using a linked list. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Introduction of priority queue. Priority queue is an abstract data type, abstract data structure. And priority queue is a special queue data structure that is very different from the normal queue. It is a linear data structure just like the normal queue. It maintains the order of its elements with respect to their priority. This is the feature that distinguishes it from the normal queue or an ordinary queue because the elements are ordered with respect to their priority. The priority can be higher or lower. We can order the priority queue in ascending or descending order. So priority queue is not a FIFO, first in, first out data structure like the normal or ordinary queue data structure. Serving is based on the priority of the elements. If we are implementing lower priority queue or min priority queue, the lowest priority element will be removed first or served first. If it is implemented with a higher priority or descending order queue, the higher priority element will be served first. Implementation. Priority queue can be implemented using various data structures. We can use a lot of different things to implement a priority queue. For example, we can use arrays. Arrays can be dynamic or fixed size. Dynamic arrays can grow as per need. We can use linked list. We can also use a binary heap, either min or max. Min heap will be best suited for priority queue with the minimum elements, minimum priority elements, and max queue is good for the higher priority or descending order priority queue. And we can also use binary search tree to implement the priority queue. Priority queue complexity analysis. So because there are a lot of different options to implement the priority queue, so their runtime also differs. For example, insert or enqueue function. If we are using array-based implementation, best, average, and worst case as we insert at the end of the array element, it is O1. So linked list base, it will be O and worst case or average case. But we can achieve O1 if we use a tail reference or the list is empty. So the new element will be inserted in O1 time. In case of binary heap or a binary search tree, the runtime will be O log n in the worst and average case. And as if binary heap or the binary tree is empty, it will be O1 runtime. This is the runtime analysis of enqueue function. Now the dequeue function. If we are implementing the priority queue using array-based implementation, the runtime will be On because in average and worst case, because on every dequeue or removal from the front of the queue, we have to shift all the elements towards left one position. So that will cost us On time because n is the number of elements we have to shift towards left. On in case of there is only one element because we do not need to shift any element. So it will result in O1 best time. So in case of linked list implementation, it is O1 in all cases, best, average, and worst cases. Does not matter how many elements are in the linked list. So runtime of the dequeue will be O1. For heap and binary tree implementation, the runtime will be O log n because O log n is the traversal cost of binary tree and binary heap. For average and worst cases, it is O1 if there is only one element in the queue. So the best case for the binary heap and binary tree will be O1 in case of there is only single element. Complexity analysis continued. So the peak function in arrays, and linked list and heap implementation. It will cost us only O1 if we want to pick or see the first element in the set, in the priority queue. In case of binary search tree, it has the complexity of O log n. O log n is the maximum cost of traversal between the binary tree nodes. So it will be the cost of average and worst case. It can also be achieved O1 if there is only one element in the binary search tree. Whether we have one element or we have lot of elements, it is quite fast to traverse within the binary search tree. Space complexity. Space complexity is On, where n is the number of elements stored in the queue. The memory is dynamically allocated in case of the implementation of linked list, heap, or binary search tree implementation. So we do not need to worry about how many number of elements we are going to store within the priority queue. The array-based implementation can be fixed size or a dynamic size. In case of dynamic arrays, the size can grow as per requirements. That is all about priority queue. And thank you guys. Let's code. Thank you. Hello guys. Let's implement the priority queue based on a linked list. And I have created NetBeans project and added 3 classes. The one class is event class that will contain or encapsulates the name of the event and the priority. And this class we will use to store within the priority queue. Let me add node class also. Node class will represent the link between the nodes of the priority queue, that is based on linked list. Okay, so let's start with the event class. So event class will have name of event, and the priority. Private int priority. Okay, the constructor will take the name and priority. Event name at param, event name of event at param, priority of the event. Set to the class fields. Event name is equal to event name. This dot priority is equal to priority. Okay, the rest of functions will be getter and setter method for the class fields. So we can insert them from the insert code, select getter and setter, and select both the fields and generate the code. So this is enough for our event class. This is a very simple entity class that we will use to store within the nodes of the priority queue. You can use your own class or whatever data type you want to store within the event, or any name for the entity class you want to use. So now we need to implement the node class. So we will store event here, private event, and next pointer. Of the node, or you can say link or reference. Reference is appropriate with context to Java. and pointer is normally used in C++. Private node next. So when we initiate the node, we pass the event here in the constructor at param event to store. Okay, store it to the event class field and set the next pointer to null. So we need getter and setter methods, so we generate them. Insert code, select getter and setter, select both the fields and generate. So that is our node class. So let's move to priority queue class. So this class will implement the priority data structure using a linked list. So we need front of the queue, private node front, and let's say element counter, private int count. So initially when we create the list, this will be an empty list. Front is equal to null and count is equal to 0. Okay, now the more important functions, public and let's say boolean enqueue. So we pass event function to insert or enqueue new element of event into the priority queue. So this will maintain, number one, maintain the order of events according to their priority. So we can adopt two strategies. Number one, ascending order. Okay, in this case we remove from the end. Number two, descending order. We remove from the front. Okay, now event to store and return true if added. Okay guys, let's begin. Create node to insert. In this video I am not going to create a separate method to insert at the front of the queue. So node is equal to new node and pass event to it. Okay, now if the priority queue is empty, if this dot is empty, let me add this function, public boolean is empty, return front is equal to null. Function to check that this priority queue is empty. Indicate queue is empty or not. Equal to sign. Okay, now let's check another condition. If the list is not empty, if this is empty, let's say, or if this is empty and if it is not empty, then the priority of the event is less than the current element stored on the front of the list. So front dot get event dot get priority is less than event dot get priority. So in this case we will insert this new event into the front of queue. So node dot set next is equal to head and head is equal to node. Okay, in case of empty, this is head is always null. So it has no impact on the node's next pointer. So but if the priority queue is not empty, the head should be stored as the next pointer to the node class, new node. So these two lines will be sufficient to handle both the cases. Let me write here. Handle both cases. Number one, priority queue is empty. Number two, new event priority is less than event stored at head or front of PQ. Okay, this is more than enough. Okay, next, find the location to insert new event. Okay, so node current is equal to front, navigate to find the appropriate location or correct location, while current dot get next is not equal to null. It means we reach to the last node, and current dot get next dot get event dot get priority is less than new event dot get priority. So as long as we are not at the end of the priority queue, and current the next node of the current node event priority is less than the new event priority, so we move to the next node. Okay, so once this loop exits, there are two situations. Number one, we are at the end of the priority queue. So what we will do, if current dot get next is equal to null, it means we are at the last node. So we simply set current dot set next and node. Otherwise, we are somewhere between the priority queue. So we set the next pointer of new node and also the current node. So first current node dot set next, current dot get next. Update the next pointer reference of new node to the current node next node of the current node. Okay, now update next pointer or reference of current node to point to new node. So current dot set next node. It is necessary to follow the order. First update the next pointer or next reference of new node, then update the next reference of current node. If you don't do that, it will be erroneous. Okay, now update count and return true. So over enqueue method is done. Now let's do public, let's say event dequeue the last event from the priority queue, that is highest priority event, because we are maintaining the ascending order. Events in ascending order of priority. Return highest priority event. Okay, so if the priority queue is empty, priority queue, if this dot is empty, so we simply S out this priority queue is empty and we return from here. Okay, return null. Now if the data, we need to traverse to the end of the list and remove from the end of the last node in the priority queue. So node current is equal to front and pre is equal to null. Use two references. Okay, now loop while current is not equal to null. Okay, and we navigate. Pre is equal to current and current is equal to current dot get next. Okay, now we reach this way, we reach the end of priority queue. Cost is ON. In case of one element, it is O1. Okay, now we update the pointers. So pre dot set next is equal to null and reduce the size. Count minus minus, and let's store the data also. Event is equal to pre dot get event and return it. Okay, this is our DQ function. Now next, public and event and peak. To peak on the highest priority event, return highest priority event. This is the front of priority queue. So we will do same thing. Loop till the end of the priority queue. So we don't need two pointers, we use single pointer. And we don't need pre here, so we reach at the end of the list and task is equal to event is equal to null, and until this is not reached, so we store the event is equal to current dot get data. Okay, we can do another thing also. If event dot get next, current dot get next is equal to null, only assign when we reach to the last node, so improve performance. This is get event. Okay guys, now we have the last element here, so we just return it. Return event. So this is our peak function. Now public int size, return count, size of the priority queue, number of elements. Okay, next we need a print function. Public void print the priority queue. So if empty, notify. S out, this priority queue is empty, and return from here. Okay, now we navigate. Node current is equal to front, S out, open square bracket and percentage S, and current dot get event dot toString. Move to the next node is equal to current dot get next. Now loop for rest of elements while current is not equal to null. So we print comma percentage S current dot get event and next node get next. So this is how we print the priority queue. Okay, so we need to add toString in the event class. Public string toString and return string dot format percentage S and percentage D. So event name and priority. Override notation and return the string representation. Okay guys, our classes are ready for testing. Okay, let's go into the tester class. Okay, we create a object PQ object. Priority queue PQ is equal to new priority queue. Okay, insert some elements, create some events. Okay, event E1 is equal to new event. Okay, let's say event 1 and priority is equal to, let's say 7. Okay, let's copy these and we update the fields. I think 5 is enough. Let's change the field names 2, 3 and 4 and 5. Okay, 2, 3, 4 and 5. Let's change the priorities. This one is, let's say 3 and 2 and 9 and let's say 5. Okay, now we insert and print. So PQ dot add, sorry, NQ E1 PQ dot print. Two, 3 and 4 and 5. Let's check it. So let's run it to see the order of the priority queue. Okay, so we inserted event 1 priority 7 and then we inserted event 2 whose priority is 3. So 3 has lower priority than 7, so it comes before 7. Same way we inserted the other events and the order is maintained, ascending order 2 and 3 and 5 and 7 and 9. These are the priorities. So this priority queue is sorted in ascending order of the priority. Okay, now let's check the peak function. S out front of PQ. PQ dot peak. It is always the highest priority element. Okay, let's run it. Okay guys, so in priority queue the front element is always highest priority element. So 7 is the only element that is the front element. Okay, then we inserted 3 and 7 already there, so the top element is 7. Then we inserted 2, still the top element is 7. Then we have inserted 9, so 9 becomes the top element because it is high priority element. Then we inserted 5, 9 is still the front element because it is the high priority element. Now the DQ function. So DQ while not PQ dot is empty. So we run top element and removed. So PQ dot DQ. Okay, and let's print the so let's run it. Okay, so here we are, removed 7, sorry, removed 9. Let me check. Okay guys, there was an error in the remove function and it is fixed now. Let's run it. Okay, priority queue tester. So here first 9 removed, 7 removed, 5 removed, 3 removed and 2 removed. Okay, here is the priority queue. This is the current state of priority queue: 2, 3, 5, 7 and 9. So first of all we removed 9, then we removed 7, and then we removed 5, and then we removed 3, and at the end we removed 2 in the order of the priority, in ascending order. That is it guys. This was priority queue implementation using linked list. I hope you have learned a lot from this tutorial. If you have any question, you can post a comment, I will reply. And if you have not already subscribed to my channel, please subscribe and promote the content. And see you guys in the next video. Thank you and take care of yourself.